Build my home on hollow ground. Too proud to grow.
Hi, this is Craig Smith with a new podcast about artificial intelligence. In the biblical book Genesis, humanity is united by a single language, allowing them to collaborate on massive projects, including a tower to reach the heavens. Angered by man's audacity, God famously confounds their language so that they can no longer understand each other, and humankind is divided and dispersed among different tongues. Well, thanks to machine learning, language barriers are falling and man may soon be united linguistically again, this time through simultaneous translation technology. Researchers at Baidu, the massive Chinese tech company, are on the cusp of creating an artificial intelligence system that will allow people from different languages to speak to each other with only a few seconds delay. Deep learning, as anyone paying attention knows, has revolutionized machine translation. Google's translation app on your smartphone or the internet telecommunications service Skype already offer real-time translation of conversations, but those systems translate speech consecutively, sentence by sentence. Baidu has gone further with a system that translates simultaneously from speech to text. Soon, the company says it will offer simultaneous speech-to-speech translation, effectively erasing language barriers. The technology is in its very early stages, but given the speed at which it has advanced, it holds the promise of uniting mankind linguistically in the not-too-distant future. I spoke with Liang Huang, the principal scientist at Baidu Research in Silicon Valley, about how he cracked the simultaneous translation code and about Baidu's successful research model generally. I hope you find the conversation as exciting as I did. I'm here with Huang Liang, or Liang Huang,
either way,
depending on which direction you want to read it, from Baidu Research in Silicon Valley. And you're going to begin by introducing yourself and telling us about your research.
Okay, great. My name is Liang Huang, and I'm a principal scientist at Baidu Research Silicon Valley, and I'm also a professor at Oregon State University. So recently we made a breakthrough in simultaneous translation. The previous real-time translation technologies are real-time but not simultaneous. So what's the difference? Well, real-time translation like Skype is consecutive in the sense that you have to finish a sentence before the translation starts. So it will not start a translation when you are speaking. You complete a sentence, then it calls the translation engine to translate for you. So that's a typical consecutive translation scenario. When presidents of China and the US meet, they employ such kind of consecutive translation using human consecutive interpretation. President Xi Jinping speaks a sentence in Chinese, then somebody translates into English, and President Trump responds in English, and somebody else translates back to Chinese. So this mode is real time, but it will cost you a doubling of the time. So 1 hour conversation now needs at least 2 hours to finish. In a conference setting, when you use consecutive translation, then it renders the audience largely out of sync with the speaker. For example, the speaker is on to the next slide, and you are still reading the translation of the previous slide. So we wanted a technology that is really simultaneous. That is, you're only lagging behind by about 3 seconds. So a 1 hour conversation can be done in 1 hour plus 3 seconds. That is the service that many diplomatic situations use. When President Trump and President Xi Jinping met in Florida last year, they actually used simultaneous interpretation, human simultaneous interpretation.
Problem with simultaneous translation is that there's actually a very limited pool globally of people who have that ability to translate simultaneously.
That's right. There was reportedly only 2,000 to 3,000 simultaneous interpreters worldwide, and the United Nations hired a lot of them, European Union hired a lot of them, and each country's Department of State hired a lot of them. It's extremely difficult for human beings because you have to do the understanding or comprehension in one language and production or speech in the other language. With the limited capacity of human brains, it's just really difficult to do. So each simultaneous interpreter can only sustain for about 10 minutes. And there is a study that shows after just minutes of interpreting, their error rates grow exponentially. The best human interpreters can only retain about 60% of the source language material.
So they're actually losing 40%.
They strategically do that for a reason, because if they try to cover everything, then they're lagging behind even more. They try to be in sync as much as possible with the speaker, so they have to kind of intentionally drop about 40% of the material.
Tell me how you got hired by Baidu.
So I got hired by the senior VP of Baidu, Dr. Haifeng Wang, who was a very senior person in natural language processing. We have known each other for more than 10 years. So he approached me and hired me, and the first task he suggested that I work on is the simultaneous translation project. And I knew this problem was ridiculously hard, and it's kind of the holy grail of artificial intelligence. And I actually worked on it for about half a year in Oregon State University before I joined Baidu. I knew it was extremely hard. So I cannot promise that I can solve this problem, I can deliver, but I will spend my time to think about it. And then I got the eureka moment. So this is so difficult, mostly because of the word order difference between languages. So think about German. Maybe many of you understand German. And German has a very peculiar word order, which is called verb final. In the embedded clauses, verb comes at the end. In the matrix or main clauses, the verb comes at the second position. But English is SVO, which is subject, verb, object, very normal. Chinese is a mix of SVO and SOV. So when you translate from German to English, you often have to wait a long time, about 5 seconds or 10 seconds, until you heard the German verb. There's a famous joke in the European Union, or maybe even the United Nations, that whenever a German speaker speaks, the interpreter is often got stuck and doing nothing. And then people would ask the interpreter, why you're not translating? And he would say, I'm waiting for the German verb. Chinese is kind of like that. In Chinese, verb often comes at the very end. Chinese is a mix of SVO and SOV. In this particular sentence, Bush president in Moscow with Russian President Putin meet, the verb meet comes at the very end. But in English, we have to translate into President Bush meets with Russian President Putin in Moscow. So if we don't want to wait until the German verb or until we heard the Chinese verb, what can we do? So we have to be more in sync with the speaker. We cannot be lagging behind for a long time. So what I realized suddenly one day when discussing with my student Minbo, who was the first author of this project, is that sometimes we can be anticipative. We can go ahead of the speaker and predict what they're going to say in about 5 seconds into the future. And we can do that with pretty good confidence because once you heard Bush president in Moscow, for example, what can he do in Moscow? He has to meet with somebody, likely Putin, with enough information, with enough training data, this kind of context. Not just President Bush, but maybe President Obama or President Clinton, not just Moscow, but maybe in Paris or Beijing, meet with somebody. So you have a lot of sentences like this in the training data. You know that a president of the United States in Moscow is likely to be meeting with somebody. So you can predict the verb meet with pretty good confidence. So this is my eureka moment. Got this kind of weight K model. It's called prefix to prefix model, where you don't rely on the full sentence. You just rely on the first, say, 2 words. First 2 Chinese words to predict the first 1 English word. And the first 3 Chinese words to predict the first 2 English words. And when you have first 4 Chinese words, Bush president at Moscow, then you go ahead and predict the 3rd English word is meet, long before you heard the Chinese verb for meet. So this is anticipative, and by doing so, we were the first system that can achieve latency requirements. For example, if I want you to be just within 3 seconds delay, or within, say, 4 seconds delay, now we can do that because of this weight K model with anticipation.
And so you set the requirement.
Yeah, the user can set the requirement himself.
You set the latency.
Is that right?
And then the loss factor depends on the latency.
Exactly.
The loss factor goes up if the latency is
So
lower.
there's a trade-off between latency and the quality. With more latency, you have better quality. With low latency, you have expectedly lower quality. It also depends on the language pair or the language direction that you're translating. For example, if you're translating between French and Spanish or between Spanish and Italian, you probably only need to wait 1 word, or you can do very low latency and almost word-by-word translation. But if you're translating between German and English, especially from German to English, you have to wait longer. Say from Japanese to Chinese or from, say, Japanese to English, you also have to wait longer, right? It really depends on the direction. From English to German, you have to wait less than from German to English.
And what happens, for example, if the verb turns out to be wrong?
Yeah.
Does it self-correct?
That's a very good question. So human interpreters, when realizing a prediction error, they attempt to correct if it's a major error. If it's roughly okay, like a paraphrase, they would not correct it. Because attempting to correct mistakes in interpretation would cause them to be more lagging behind, more out of sync with the speaker. First of all, they only do anticipation when they're quite certain. And in the cases where they made a mistake, they attempt to correct it. So far, our system does not have the capacity to correct mistakes. We don't correct mistakes like this. But in the next version of our system, we will. So we are actually developing ways to detect and correct mistakes.
And will that, as in dictation, then erases and rewrites?
Right, so there's 2 options. One is erases and rewrite. That would work for speech-to-text translation because the text display you can always rewrite. We currently don't do that for 2 reasons. One, constantly rewriting the translation would be kind of annoying to the user because the user sees constantly going forward and going backward. Secondly, more importantly, so we are anticipating a more important application, which is speech-to-speech translation in the future, maybe next year. And in speech-to-speech, you cannot retract a word which you have already said. this is sound which you cannot retract. So we are kind of thinking in that direction, or we can't actually erase and retranslate. We'd better just say, oh, I'm sorry, I made a mistake or whatever. Be developing those kind of technologies.
And talk about speech-to-speech. You're also working on that in Silicon Valley?
Yes, but that's a more long-term project.
What are the challenges there from the science point of view?
The major challenge that we have not been able to do yet is the missing step from text to speech. That is from the translated text to the translated speech. So currently there are 3 steps in speech-to-speech translation. The speech recognition, which recognizes source speech to source text. So from Chinese speech to Chinese text, Chinese characters. Then what we do here in particular was translating from Chinese text to English text in a simultaneous way. But there is a third step that is generating speech simultaneously from English text so that you can complete a loop from speech in Chinese to speech in English. So the third step, simultaneous text-to-speech synthesis, is the thing that is missing. And that is also very challenging, and we don't have a good way to do it yet, but we are actively working on it.
Although the latency from text to speech should be less.
It should be less, but still current technology also rely on the whole sentence. Right? Current text-to-speech synthesis rely on the whole sentence to do it. Because you have the full sentence, then you can do the prosody very well. Say, for example, you know at the end of the sentence that it's actually a question sentence, then you do rise it. Right, but if you don't know it at the beginning portion of the sentence, then you cannot plan very well. So you have to have some knowledge of the global structure of the sentence or some prediction of the future.
This predictive model that you have, what is the error rate?
In Chinese to English translation, at least we have some numbers. A wait 3-word model, roughly speaking, that would translate to waiting about 1.5 to 2 seconds, so about 2 seconds behind the Chinese speech, would have some degradation in quality. But if you wait 5 words, the degradation is less. So 5 words is roughly speaking 3 seconds, because Chinese speech is roughly 2 to 3 syllables per second. And Chinese word is always about 2 syllables. So roughly speaking, the take-home message is that our simultaneous translation with about 3 seconds delay is about 3.4 blue score less than full sentence translation. Full sentence translation meaning consecutive, that you have the full sentence, then of course you can do a better job. So we're about 3.4 blue scores less. We're constantly improving that number.
What is blue score?
Blue score is a standard metric of translation quality by comparing machine translation output with the human translation reference. So for example, I have 10 sentences in Chinese, and then I ask a machine to translate into English. I got 10 English sentences output. And then I also ask human beings to do these translations, and I compare their translations. How close is your machine translation to the human translation? If it's very close, you use a lot of same words or same phrases, then you get a higher blue score. If you're very different, that no word is the same, then you got 0 blue score, for example. So this 3.4 blue score is a noticeable difference. It's definitely a noticeable difference, but it's the price you have to pay if you want to achieve simultaneity, right? So there's, again, a trade-off between latency and quality.
But you would call it acceptable?
Acceptable kind of a degradation in quality than the full sentence translation.
And given that you've only been working on this since
like April.
Do you expect that would improve?
That would improve, yes. And this is really the first system, the first approach that can achieve a given latency metric. Previously, you cannot say, oh, please be at most 2 seconds delay, or please be at most 4 seconds. You cannot specify that. No previous approach can achieve a given latency requirement.
Yeah. How long do you think before this is commercialized?
So it's kind of our internal product right now, and we used it in our Baidu World Conference, which is a public conference. A lot of international conferences are happening, and a lot of them want to have simultaneous interpretation or simultaneous translation services, but it's extremely expensive, right? Because as I said, the availability of such qualified interpreters is a problem. There's a huge demand for it, right? But there's not enough supply.
And you think speech-to-speech is a year away, or?
At least half a year away.
Yeah, that's amazing.
It's ridiculously difficult.
Yeah.
It's even more difficult than the simultaneous text-to-text translation we're doing right now. The 5 words or about 3 seconds delay is still a lot better than the 12 seconds delay or 1 sentence delay in the previous technology.
I wanted to talk a little bit about Baidu Research in general.
Sure.
How much research in China today is being seen? There's much less focus on publishing and a lot more focus on getting products done. And so the question is, are there advances in China that we don't see?
That's a very good question. I think there's a lot of advances in basic research and in applied research in China, not just products. Of course, we made great products like WeChat, like Alibaba, like Baidu Search, a lot of stuff. But China also invests in basic research. So you can see that a lot of not just Chinese authored papers, but also only mainland Chinese authored papers from universities or companies within the mainland China is increasing very rapidly. In the past, maybe 15 years ago, it's very, very low percentage, but now it's huge.
That's right. That's all open research that everyone sees. Is there research that is not being published because companies are just too busy to publish?
That's also possible. In Baidu, we still encourage publishing. Another reason why we have an office in the Silicon Valley doing a little bit more long-term research. This kind of geographic and time zone separation between Beijing and Sunnyvale is huge. Sometimes it's a huge disadvantage in collaboration, but sometimes it is an advantage that we have slightly more freedom in thinking more long-term. People in Baidu Research in Sunnyvale focus more on long-term directions and hard problems, like the hardest problems that nobody knows what the answer about. Collaboration mode, which I call tech request. So these projects, like simultaneous translation and many other projects, were initiated by the headquarters. It's not something that I myself would choose to do as a first project in Baidu Research, right? Because it's too risky. But they requested us to do it. And after we did it very quickly, then they took it over and they also very quickly integrated into theirs. So everything is very fast. In this mode, I call it the third route of industrial research. Microsoft has the first route, which is tech transfer. And Google argued that it does not work. And Google is quite correct that Microsoft way does not work very well. In my experience, it doesn't work because whenever you had a paper, you think it's a great paper and has great results. The production team just don't care because you work on a small toy problem, on a small data set, on a weak baseline, and they have a much larger data set, much more complicated system. And what you see as a huge improvement on your paper would reduce to a very tiny improvement on their paper. It's not worth the time and effort for them to implement your idea. And often you work on something that they don't care that much about. You're not solving their most difficult problems. So what they have is the other problems, more difficult problems. And they would do this tech request, which I call the third route, because Google has the second route, which is integrated. I used to be a Google scientist. 10 years ago, I was a Google research scientist. And Google employed an integrated philosophy that is asking scientists to write production code or near production code from day one. That model kind of works better for production, but it imposes more burden on research scientists because research scientists need to do two jobs in one role, scientist and engineer. It's a little bit conflicting with each other. So at Baidu Research, we have the third route. That is the production teams request hard problems to us. It's always the most difficult problems. And then we cannot promise that we can solve them, but we think about them. And we can solve many of them. And like in this case, simultaneous translation is initiated by their request. And then we did it. And then because they asked us first, so they're trying to buy this thing from us. And once we did it, they took it immediately. So tech transfer is immediately super easy. I just told them the idea via teleconference and they immediately realized that's a great idea and it took them only a week to implement it. In the tech transfer model in Microsoft Research and other companies, researchers initiate a transfer. That often doesn't work. You're trying to sell something to the production team. That doesn't work. If they're trying to buy something from you, they will definitely take it once you did it. Again, it's a tech request model. It's kind of reverse transfer.
But generally, this question of visibility into what's happening in AI in China, you think if someone like me follows arXiv, I see pretty much everything that's happening in China?
Yeah, a lot of Chinese companies and universities archive their papers, like this paper was archived in November. So Chinese companies and universities definitely do a lot of publishing, for sure. I myself don't think there's a reason to hold on to publish. Maybe some companies do, but Baidu doesn't. Many other projects in Baidu Research even got open sourced. So our researchers released their code almost immediately after the paper was published, or even immediately after the paper was archived. So
this is open source?
This is not open source yet, but the idea is so simple that anybody in the world can implement it very quickly. Anybody reading the paper would be impressed how simple that is, and seemingly is, but actually it's very deep. But the implementation is quite easy. In a sense, it's very close to being open sourced.
There's been a lot of talk about this. China's pouring a tremendous amount of money into AI research.
That's correct.
The U.S., at least in the private sector, pouring a lot of money into AI research. Right. Who's ahead or who's going to be ahead?
Right.
How do you feel about that? You straddle both.
Right. So I think Baidu is very open to collaboration with not just companies and universities in China, but also companies and universities in the States and outside of China in general. So we are very open to publication, to collaboration with universities in the States and in Europe.
I'm trying to figure out just personally or as a journalist whether that's a red herring, whether there really is competition.
I don't think there's a competition in the sense that research is all about building on somebody else's work, standing on the shoulders of the giants. Either you're in China or in US, you read papers from both sides. each of us was just building upon other people's work. To me, there's not such competition in AI. And I think it's a good thing that both governments are investing a lot, and both private sectors in both countries are investing a whole lot in AI. That's great for both countries. The technologies developed here can be used there, vice versa. It's all open source, all published.
Where do you think this simultaneous translation will go? What's your vision?
So next step, as I said, would be simultaneous speech-to-speech all the way. So right now, it's only speech-to-text. If you can do simultaneous speech-to-speech, that's much, much better. Baidu has a device called Wi-Fi translator, but it's doing consecutive translation right now. If this device can do simultaneous translation, then you can save a lot of time by traveling to Japan or Germany. Right now, you use this to order food in a restaurant, but it costs you twice as much time. But now with simultaneous translation, if you go to a conference employing our technology, the conference is in German, then you can still understand it very well. With this consecutive technology, you cannot date someone. With simultaneous interpretation, you might be able to. If you have a headset and the left track is speaking Chinese and the right track is speaking English, then you can do this simultaneous interpretation. You can talk to another person in a different language, completely not understand each other's language, and you can talk to each other and probably even date each other. And that would be wonderful.
That's fascinating.
Yeah. Even though this is kind of trying to replace human beings, it's not our intention. Human interpretation is still needed in many situations, like maybe President Xi Jinping and President Trump meet, because they need very high quality translation, and the machines are not there yet. We are trying to make this technology more available and to reduce the burdens of human interpreters, not to replace them.
For those of you who want to go into greater depth about the things we talked about today, you can find a transcript of this show in the program notes, along with a link to our Eye on AI newsletters. Let us know whether you find the podcast interesting or useful, and whether you have any suggestions about how we can improve. The singularity may not be near, but AI is about to change your world, so pay attention.
No, I can't get close till I buy my time.